Today we're going to talk about this interesting effect known as the Larsen Scanner. Hey, what's happening, guys? Today we're going to talk about this. This is a variation of the Larsen Scanner. The actual Larsen Scanner should have little trails on these, but we're not going to worry about that. Anyway, it was named after Glenn Larsen, who was a famous TV producer behind Battlestar Galactica and Knight Rider. So that's where you know this little effect from. The scanner on the front of Kit's car, you know, the zoop, 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 zoop. It's a super easy to effect to create. Now, I've done it with an Arduino because that's probably the easiest way to do it. And I've added in this pot that I can use to control the delay. And I just want to use that so that you can understand what is going on. So all the Arduino is doing is saying, these are attached to pins 2, 3, 4, 5, and 6. 2 on, 2 off. 3 on, 3 on, 4 on, 5 on, 4, 3, 2, 2, 3, 4, 5, 6, 5, 4, 3, 2. That's all it's doing. It's turning them on and it's turning them off. And then, like I said, we've just used this pot to adjust the speed to give us a nice effect, a little ping pong effect. So, there you have it. Super simple. Thanks for playing. But no. If you follow this channel for any length of time, you know that I love discrete components, and I especially love the 555 timer. So, let's make this with a 555 timer and a CD4017 and some diodes. Why diodes? I'll show you. Alright, so the first thing we need is a clock signal for the 4017. It's just a pulse, bing, 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 to tell the 4017 when to increment. There's lots of ways you can do that. You know me, I love the 555 timer. So what I've got here is a 555 set up in what I call the most simple way to set up a 555 timer. You connect pin 6 to pin 2. You put a capacitor between pins 1 and 2, with pin 2 being the anode. And you put one of these little trimmer potentiometers between pins 8, 7, and 6. Pins 8 and 4 go to VCC. Pin 1 goes to ground. Pin 3 is your output. Now, I am using a 33 microfarad capacitor here for timing. That's giving us what, about, whoops, maybe 2 hertz, 2.5 hertz, somewhere in that range. Let's get an oscilloscope here, and we'll check that signal. That should be about right. Yep, I don't know how well you can see that, but let's zoom in. That's saying 4 hertz, 7 hertz, 5 hertz, 0 hertz, 5 hertz. Whoops, wrong button. Trying to zoom in on the wrong screen. And from look at that, bum, 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 bum. It's barely over, it's around 2 hertz. It's hard for scopes to measure anything under 10 hertz, but you get an idea. There's the signal. And you can see our mark in space, which we can adjust like this. There's more of a 50% mark space. And if I turn it the other way, that's maybe in 90% mark space. You can see the on is much more than the off, so let's adjust it. Try and adjust it right around 50%. Let's see here. Measure. Duty second. There we go. I don't want that. Now it doesn't want to measure. Yeah, that's the problem with these when they're so slow, they won't measure. Anyway, you can see it's close to 50%, which is fine. That's what we want. So now we have our clock signal. The next thing we need to do is get our 4017 and put it there in the breadboard. Okay, so there's a 4017, and this is how we're going to hook up most of it. Pins 16 and 12 go high, 15, 8, 13 go low, 14 is our clock, and here is our firing order, which we need to talk a little bit more about. But first, let's get these pins hooked up so that we have power and ground and clock to the 4017. Okay, so we've got our high pins 16 and 12, we've got our low pins 15, 13, and 8. So next thing we need to do is carry over our signal from the 555 timer, pin number 13, and that goes to the clock, which is pin number 14. So there's our clock pin over. All right, I've added in our 5 LEDs and the accompanying current limiting resistors. So now we need to look at our firing order and line them up. So the first one is pin number 3. Let's go down here. 1, 2, 1, 2, 3. And that goes to the anode of our first LED. The next one is pin 2. That goes to the anode of our next LED. And then pin 4. Who came up with this firing order? This is madness. And then pin 7. And pin 10. 9, 10. Yeah, I'll go up here. Okay. Yeah, maybe I'll bring it down here so it's not in the way. Get out of there. So what will happen now is when we apply the clock signal, it'll count 1, 2, 3, 4, 5. Then it'll also count 6, 7, 8, 9, 10. Then it'll come back and do this again. So what we want to do is we want to go from the next pin in the firing order, which is pin 1, to our reset pin. And what number is reset? It is number 15. So we will remove our ground from the reset pin. We'll connect pin 1 to pin 15. And then when we power this guy up, we should get, zip, zip, it won't go backwards yet. Okay. We got a little bit of crazy going on there. So, what could be causing that? Well, it could be a number of things. Let's get the oscilloscope and take a look at our output signal. So there's ground. And we'll connect up here to pin 3. The output signal doesn't look too bad. But just for fun, let me go ahead and take this off of here. And let's add a decoupling capacitor across the 555 timer. What do I got handy here? 10 microfarad. A little bit much for a decoupling capacitor, but we'll see what it does. Oh, look at that. The decoupling capacitor just straightened it right the hell out. I love it. Okay, so now we're going in one direction. Now we need to go backwards. So what we're going to do is we're just going to use the next 3 pins, 1, 5, and 6, and just come back here. So we're going 1, 2, 3, 4, 5. Then we're just going to go 6, 7, 8 back to those 3. But we can't just do that. We can't just add another wire from those pins into here. It's going to cause us issues with the timing of the chip and everything else. So what we need to do is we need to use some diodes. And I just happen to have some. So let's disconnect here. And I'm going to disconnect all of our LED pins like that. And I'm going to move these each down just so that I have some more room to work here, that's all. Like this. They're staying in the same columns. I'm just moving them down so that I have an empty row up here to work with. Then I got some diodes. These are just little Schottky diodes, will be fine. And we will put them across here like so. Cathode of the diode to the anode of the LED, which is in effect another diode. Now you really only need to do this for the middle 3, but because there's going to be a voltage drop, even though it's not much, there's still going to be somewhat of a voltage drop here. I'm going to add it to all of them so that we're even across the board. That way our brightness stays relatively the same and it doesn't look too funky. Okay, so now we go back to our firing order. First one is pin 3. 1, 2, 3. That's our first one. Then pin 2. That's our second one. Then pin 4. Our third one. Then pin 7. That's our fourth one. And pin 10. 9, 10. That's our fifth one. Then we go pin 1. Comes back to our number 4. And then pin 5 comes back to number 3. And pin 6 comes back to number 2. And then pin 9 is our reset, and that goes to 15. So, if I did this correctly, we should now get our Larsen scanning effect. Of course, the chances that I did everything correctly the first time are slim and none. As you can see, that's the way it usually goes. What have I done wrong? Let's take out the reset pin, or the reset pin. That's not making any difference whatsoever. Is it a voltage problem? It should not be a voltage problem, but I'll tell you what I'm going to do. I'm going to increase, we're at 6 volts. I'm going to take it up to 7 volts just for a second. See if that makes any difference. No. No difference at all. So, let's pull all these out of here. And we'll start again. And just make sure that our initial thing was working. So there's 3. That's strange. 2. 4. Okay. 7. That's the way it always goes. 10. Next up, number 1. Okay. Here's what we're going to have to do. I can already tell. They're going to have to be double isolated. That makes things more interesting, right? All right, let me get some more diodes. All right, I've got some more diodes. And if I tilt it like this, it works. Usually. Why are you sticking there? As you can see, we are totally unscripted here at Learn Electronics. Okay, so our next one is pin 1. I'm going to put it here. And then we'll take off from here and come over to here. Come on. What's going on here? There we go. So after pin 1 is pin 5. That's 5 there. And we'll come here. There we go. After pin 5, it's pin 6. Yeah, I have to get sneaky here. So, 1, 2, 3, 4, 5. That's pin 6. I'll bend it up and over here. Come on. We also need to do pin 9 to 15. There we go. And there's our Larsen scanner. Pretty cool. You want to change the speed? Change the capacitor between pins 2 and pin 1. I hope you guys enjoyed this. If you did, please give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you guys for subscribing. We're at 92,200. When we get to 100,000, we're going to do a lot of giveaways. So far, we've got an Arduino and Raspberry Pi sensor kit and a soldering station. And there might just be an oscilloscope in there too. So if you haven't subscribed yet, what's keeping you from it? All right, that's it. I'm out. Peace.